Okay, this is just a quick description of how you can apply exponential functions. You'll notice that up here at the right, I have a basic exponential function written down in sort of the application form. Remember, 1 plus r is what's known as the growth factor. If that 1 plus r is raised to the t power, that means I'm multiplying something that's greater than 1 plus that interest rate, raised to a power. I'm going to multiply that 1 plus r over and over and over again, t times. So, Peter invests $1,000 in a bank account that earns 4% annual interest. Remember, $1,000 is what's called your principal, and that's what P stands for, is the principal. So you're going to say that, well, if Peter invests that money for 1 year, right, how much money will he have? Not just how much money does he gain, but how much money does he have after 1 year? Well, $1,000 times 1 plus 0.04 raised to the 1 year. Well, if we hop on our calculator real quick and we type in 1,000 times 1 plus 0.04 to the first, we'll find out that we have $1,040. So we can come back here and say that we have $1,040. Now, if he leaves that money in the bank account for 2 years, basically he's taking that $1,000, he's going to add on 4%, or basically 1,000 times 1 plus 1,000 times 0.04, get that extra $40. But then he's also going to take that full 1,040 and make interest for another year. Well, that's where our interest formula can really pay off. If we take that 1 plus 0.04, but do that twice, we're going to earn interest on that for 2 years. Well, let's go back to our calculator real quick. And the beauty of our Inspire calculator is we can just copy paste and put that in for 2 years. Notice that we gained the first $40, but we also gained another $41.60. We gained not only the $40 from the first year, but now on top of that, I gained another $40 on my $1,000 and $1.60 from the $40 I made the first year. We're gaining interest on top of interest. That $40 in interest we earned the first year gained us even more money. So if we do that for 5 years, we should expect even more growth. Again, we'll just take our same formula to the 5th power, and if we go to our calculator very quickly, we can type that in, change that to a 5, and quickly find out that $1,216.65, 1216 and 65. Notice that for 5 years we were gaining our $40, so that's our $200, but the extra $16.65 comes from gaining interest on top of interest on top of interest. Some interest from the initial $40, some interest from our initial $41.6 from year number 2, and interest on top of interest on top of interest. The same thing goes for anything that's growing with an increasing rate. You buy a painting for $3,450. What that tells you is the value of the painting initially was $3,450, but it's going to increase in value 8% every year. Well, I've got to keep my initial value, so $3,450 times 1. It's still going to be worth that no matter what. Plus, it's going to gain 8% each year. And as long as you're gaining that per year, right, in years, if our rate and our t line up, we can simply say that 3450 times 1 plus 0.08 to the t is our value. Well, that changes a little bit when we want to talk about compound interest, compounding things monthly or daily. The basic idea of that is I'm going to take my $1,000, just like I did before, still going to hang on to that money, but now I'm not going to earn all of my interest right at the same time at the end of the year. I'm going to say that I'm going to earn some of that money, 0.04%, each month. So I'm going to earn a 1/12 of the interest every month. But now the nice part is, not only am I getting a 1/12 of that, I'm going to get that 12 times more often. 12 months out of the year times the fact that I'm going to do that for an entire year. Your formula you can use for that is a compound interest formula over here at the right. Your principal, again, is your initial money out in front. Your A is your final value. 1 plus 0.04, my interest rate as a decimal. Okay, and it's often called an APR, an annual percentage rate. Your N stands for the number of times you're going to compound it per year. So 12 months, if I'm compounding monthly, I'm getting a 12th of the interest rate, but 12 times the number of years T. Excuse me. And if we type that into our calculator, again, just a slight adjustment to our old formula, I can go over here and say, well, let's take that 0.04 and let's put that into a fraction. And my calculator doesn't want to help us out with that. Let's go back here. All we really have to say is divided by 12. But then remember to take your number of years times 12. Remember, we're only doing this for 1 year. And if you hit enter, you'll notice that your interest rate is divided by 12 now. But at the same time, your years are times 12. And notice in 1 year, instead of just getting $40 as we had done on the last screen, we now have $1,040.74. $1,040.74. We gain an extra 74 cents. And hey, if we had started with $1 million, that'd be more than just pennies. We might have gained, $74 or $740. How much money will we have after 5 years? Well, again, same idea. $1,000, 1 plus 0.04 over 12 monthly interest, getting a 12th of the interest, but 12 times as often. So instead of just getting it 5 times, we're going to get our interest 60 times. Or just take your old formula, change that 1 to a 5, hit enter, and I've got $1,220, and it looks like 99 cents, but rounded up, looks like 1221.00 would actually be a better value. 1221.00, telling me I did round. Don't forget to give me those decimal places. But there's your final value. Now, last thing I want to show you is just taking a look at what if we change that N value. A couple of different ways we can do N. We've already talked about monthly interest. So if Elise invests $1,000, just as we did before, at 4% interest, so 1 plus 0.04 over 12, monthly interest, right? N equals 12. We're going to go to the 12 times the number of years. And notice in this example, she's going to invest for 3 years. Basically just like our previous example. So again, we can head to our calculator. And I think I'm going to clear a few of these out. So let me go ahead and head to the top of our screen. I'm going to clear this out a little bit and just put on that we're going at 3 years, but monthly interest, and that should earn us $1,127.27. So $1127.27. Now, what if we earned that interest less often? Again, we already looked at annually, but how about semi-annually? Semi-annually saying we're going to chop the year into 2 parts. So 1,000 times 1 plus 0.04 over 2 raised to the 2 times 3. Or what if we talked about quarterly? Quarters, again, chopping your year into 4 quarters. So N is going to be 4 times a year. 1,000 times 1 plus 0.04 over 4, essentially earning 1% interest, but earning that interest instead of 1 time a year, 4 times for 3 years, or for 12 times in 3 years. And finally, what about daily? What if instead of making our numbers smaller, we made it bigger? Well, there are 365 days in a year on average, so we're going to say 1,000 times 1 plus 0.04 over 365 raised to the 365 times 3. Go ahead and take a second, type those numbers into your calculator, and when we come back, we'll take a look at how did that affect the amount of money we gained. Is it better to have a large N or a small N? Do you want to earn that interest often? And at some point, can you earn that interest too often? So take a second, type those in, and we'll be back with the answers in just 2 seconds. Alright, you'll notice that on my calculator I've typed in that same formula 3 different times, but you'll also notice that up top here we've typed that in at semi-annual interest, notice a 2 in the exponent, a 2 under the fraction, quarterly interest with a 4 under the fraction up in the exponent, and 365 being daily interest, both up in the exponent and beneath the fraction. So we get our three different numbers. You'll notice that I've rewritten them on our screen here. Notice that as your n increases from 2 to 4 to 12 to 365, we are gaining money. 1126.16 versus 1126.83. 1127.27, so about another 44 cents or so, and 1127.49, so another 22 cents. So the more often you get your interest, the more often it's compounded, the more money you'll make. However, do notice that the larger and larger it got, we went from 2 to 4 to 12 to 365 times. So we're calculating that interest a lot during the year, really. Notice that we're not gaining as much every time, though. From 1126.16 at twice a year to calculating at 365 times a year, really our number didn't increase that much. About 70 cents, then 40 cents, then 20 cents. At some point that increase is going to be so small that it may or may not be worth our while. We'll talk more about that when we get to continuously compounded interest. Hope that helps you understand the interest formula and how we can apply exponential functions to the real world. Good luck.